studying that? Okay. That's exactly, we do the exact same thing as grade 11. All we do is add in one piece to it. And that is changing degrees to radian measure. Okay? So I'm just going to start with the very basic. If I have a circle, and let's say I said that was 30 degrees. Okay? So that's what we call a degree measure. Now how many degrees are there in a circle? 360. Now let's say, for all intents and purposes, that the radius of this circle is 1. Okay, so the radius for this circle is 1. That means that that distance is 1, that distance is 1. Okay, I want to be able to describe this distance right here. Now that distance is based on the angle that I've just created from the center of the circle. So that's 30 degrees that we've created, right? So how do I get this distance right here? Well, you said that it's 360 degrees to go all the way around the circle. What is the circumference of a circle? How do I find it? 2 pi r. So 2 times pi times 1. Okay? So the circumference of the circle, the distance of the entire circle, is 360 degrees, and the circumference is 2 pi. All right? We refer to this as radian measure. So much like we measure in kilometers and miles, okay, we can measure angles in degrees and radians. This is the new part of this for the grade 12 course. So if I want to convert 30 degrees, let's say, I want to convert it to radian measure, I'm going to multiply it by that ratio right there. Now I'm going to switch this ratio. I'm going to divide this ratio by 2. So I divide both sides by 2. So halfway around the circle is 180 degrees. It's also pi radians. It's half that distance of the circumference of the circle. So I'm going to change this to pi over 180 degrees. Okay? Now I'm going to leave this. I'm not going to actually multiply this out. I'm going to write it out as a fraction, and I'm going to leave the pi value there. So how do I describe 30 degrees? Well, 30 degrees is pi over 6 radians. Okay? So you can convert now any angle from a degree measure to a radian measure. And from a radian measure back to a degree measure. Now the whole purpose of this is to describe basically the distance of that arc. That's basically what the whole intent and purpose is of this, is to describe the distance of that arc. Okay, and rather than describing it in degree measure, we're going to describe it in radian measure. And again, that is brand new to you guys. So I'm going to now review what we did last year in a moment, but right now all I want to do is just take 3 angles and I want to convert them. So everything that we do from now till the end of basically Unit 5 is going to deal with the unit circle. Now the unit circle is a circle drawn on a Cartesian plane in which we have a radius of 1. That's why it's called the unit circle. Now every angle starts with my initial arm, which is right here. That's my initial arm. And every positive angle moves in a counterclockwise direction. So take a look at page 110. It says, draw the angle of 135 degrees in standard position. That means that my terminal arm starts, my initial arm starts here, and then I stop over here. That distance being 135 degrees. Okay, so this is what we call terminal position, which is your end position. Now, in grade 11 it says, okay, well what other angle also is in terminal position? Well, how do I find another angle that's also in the exact same position? What do I need to do? No. You actually kind of had it right, but
Subtract from 180?
not from 180. No, that would give me my reference angle. You're ahead of the game here. I want another angle that's in this exact same position. Right there. So what's another angle in that exact same position? How do I find it?
180 subtract whatever that value is.
Not quite, no. You guys are ahead of the game here.
It would be 360, subtract that and the negative value.
You're getting closer.
Add it.
Yes. How do I get back to that? Well, what do? I just go right to there. How many degrees is that? 360, right? So to get back to that position, I add 360 to it, or I subtract 360 as many times as I have to. So what's another angle in the exact same position with the same terminal arm? 135. The next one is tough day. 495. Right? Just add 360 degrees. Takes you right back to where you just finished. Subtract 360 degrees. Takes you back to where it just finished. Okay? So to find another angle in the same terminal position, we just simply add 360s to it and keep going. Okay, so we've done that now. Here's to answer, Alex, and you kind of answered the question for A here. It says, what is its reference angle? Now, do you guys remember, you may or may not remember, the reference angle is the angle that is always made with the x-axis. So that's this angle right here. That's my reference angle. So how do I get that reference angle?
180 subtract.
Exactly. 180 subtract that, which is 45 degrees. Okay? So, again, make a note of this. We talked about it last year, but you'll have forgotten. Reference angle. Always made with the x-axis. There's my reference angle here. Reference angle here. Reference angle right there. Okay? We'll mess it up. Somebody in here is going to draw it to the vertical. We always do. Even though I can tell you that. But it's always with the x-axis. Okay. Now it says, draw each angle in standard position, convert each degree measure to radian. So how do I change it to radian measure, 135 degrees? The same way I convert miles to kilometers. Pi radians over 180 degrees. Okay? And then reduce your fraction. Reduce your fraction. 3 pi over 4 rads. Now radians does not necessarily have to be with a pi value, because pi actually is 3.14, right? So 3 times 3.1415, whatever, divided by 4 will give you an actual decimal value. That's okay. We just try not to use it very often, but that is a possibility. Okay? They want you to convert 5 pi over 6 radians to degrees. So what do I multiply it by? Good job, Juan. 180 degrees over pi. 30. What does that leave me with? 5 times 30, 150 degrees. All right? And finally, 4. Is there a degree symbol on that in C? No. Therefore, that means it's 4 radians. So I need to convert it to degrees. And this one, well, you could reduce it, I suppose.
Why do you have pi there?
Right here?
Yeah, because for when you
Okay,
use...
hold on. I know, don't look at the book. 360 degrees is 2 pi radians to go all the way around. So I divided them both by 2. And it means that from here to here, that angle is 180 degrees. But it's also the same as pi radians.
Okay.
So that's why I used pi there. Instead of 2 pi over 360, I used pi over 180.
Oh, okay.
They're using 2 pi over 360.
It's just, I thought that when you're converting radians to degrees, you have degrees on the top.
Oh, I see. You're right. I am not. Well done. Good catch. It should be this, shouldn't it?
I think so.
Yes, you're right. So I take 4 times 180. I knew there was a reason I needed to use a calculator for this. So then you would 4 times 180 divided by pi. And you would change that to a degree measure, which I don't know what it works out to. Anybody would cut the calculator out? 4 times 180 divided by pi?
So we're allowed to use a calculator for these units?
Just for something like this. But no, we'll talk about that. You're gonna, you want to practice without, because you won't use it on the exam for this section. Except for finding angles, if you've got a ratio, find an angle. Okay? What was it?
229.183.
229.183 degrees. Okay, good. Okay, any questions on converting? Alright, this is the only thing that's going to be new to you today. Everything else that we're going to do is going to be something that we cover in grade 11. Okay, identify the angles coterminal with 210 degrees that satisfy the domain minus 720 degrees, less than or equal to 720 degrees. Express each as coterminal. I said to you here that we called it terminal position. It actually means this, coterminal, meaning shares the same position. So how do I find that? If it's degrees it's given in, what do I do to go to another one that's coterminal?
Add 360.
Add 360. What if it's radians it's given in?
2 pi.
Add 2 pi. So for example, I'm just going to look at the next part of that question, 3 pi over 4. All right, I want an angle that's coterminal to it. I add 2 pi to it. So we have fraction work here. 3 pi over 4 plus 8 pi over 11. Oh, sorry. 8 pi over 4 is 11 pi over 4. That's the next angle that is coterminal to 3 pi over 4. So if I were to draw that out, 3 pi over 4 is right here. Is right there. If I add 2 pi, comes all the way around. So there's 3 pi over 4. The next time it comes to there, it's 11 pi over 4. Because what's happened is, I started here, I went to 3 pi over 4, and all the way back to there. So it's a full circle plus the 3 pi over 4 I add to it. Okay? So if they draw it out in a box there, that should be easy for you to understand. Okay, take a look at the B on the bottom there. So it's 2 pi plus 3 pi over 4. They gave you a domain. We'll have to talk a lot more about domain in a little while. So 0 plus minus 4 pi is plus minus, how many rotations is that around the circle? 4 pi is how many rotations? 2. Okay? So you go 0 subtract 2 times 2 pi, 0 subtract 2 pi, theta add 2 pi, I keep saying 0. Theta subtract 4 pi, theta subtract 2 pi, theta add 2 pi, theta add 4 pi. And it just gives it to you as you go around the circle. Okay? It's not complicated, and I will get back to that in a bit. What I want to do right now, we've got quite a bit of time here. I want to start in on that unit circle today so that it's not something we have to look at on Monday, because it's important. I want you to get it into you now, and then when we look at it on Monday, it'll be a little bit easier after we do this. Okay. You really don't need to look at your book right now. In fact, what I suggest is have either draw it on the cover of the back of this book. Might be your place to put it if you want for right now. I am going to give you one of these, or you can just follow along in your book if you want as to how this works. Okay? So, there's two triangles that we work with. Now, I explained this to you last year, so I'll explain it to you again today. Our objective here is to find out what the exact value of very specific angles are without using a calculator. For example, can you tell me what the sine of 330 degrees is without the use of a calculator? Can you tell me what the cos of 90 degrees is without the calculator? That's our intention here. We are trying to do this, like everything else in this course, do it without the calculator. Can we do this without a calculator? So it comes down to two very specific triangles to get the actual ratios to then apply it to the unit circle. And then, excuse me, and then we eventually go beyond the unit circle to angles such as sine of 105. Can you tell me what the sine of 105 is? That's our intended goal. Can you do these things without the use of the calculator? So it starts with a 30, 60, 90 triangle. So there I have it, 30, 60, 90. The first thing that you had to remember last year, that you need to remember in order to fill this triangle in, is what is the sine of 30 degrees? 0.5, 1 over 2. So the sine of 30 is 1 over 2. Okay? How then do I find this other side here? That's right. 2 squared subtract 1 squared, so 4 subtract 1. Square root 3. Okay, right on. You nailed it. You had the most important thing. So this is triangle number 1. What does it help us do? It helps us find exact value trig ratios for the following. Now, anytime I ask you for an exact value, you are telling me the coordinates of this trig ratio. And I'll explain that a little bit better in a minute, but that's exactly what you're doing. When you see exact value, it means there's probably a square root in it, or possibly a pi, but more likely a square root. So, what is the sine of 30 degrees? 1 over 2. What is the cos of 30 degrees? Square root 3 over 2. What's the tan of 30 degrees? There you have it. Now, let's fill in what the sine of 60 is. Cos of 60. And the tan of 60. So what is the sine of 60? Square root 3 over 2. What's the cos of 60? 1 over 2. And the tan of 60? Square root 3. Okay? If at any time in this course you struggle to remember this, draw that out and remember that the sine of 30 is a half. And then from there you should be able to fill the rest of this in. Alright? You'll also notice that sine 30, cos 30, 1 half root 3 over 2, sine 60 root 3 over 2, cos is a half. You just switch them. You just switch them. Those values don't change. It's still the same triangle. Okay? The second triangle we are working with poorly drawn. Do that again. One and one. So that's 1 and 1, what does that make the hypotenuse?
Two.
Square root 2. Okay. What is the sine of 45 degrees? No. You say what? 1 over? Yeah, I thought you just said square root 2. It is this, 1 over square root 2. Now, with the tan ones I'm not going to rationalize, but with these ones I'm going to. Okay? So I'm going to rationalize this denominator, which means that it is root 2 over 2. Rationalize means multiply the top and the bottom by square root 2. Okay? What about the cos of 45 degrees? What is it? Same thing. Square root 2 over 2. And what's the tan of 45? 1. Anybody okay so far?
Why did we do that square root 2 over 2?
I'm rationalizing it. The reason is the material that I give you, they give it as root 2 over 2, as opposed to 1 over root 2. Rationalizing means I don't want a square root of value on the bottom. So I have a fraction in which I don't want the square root on the bottom. So to get rid of it, I times it by 1, or I times it by root 2 over 2.
Excuse me, Avery Knight to the office.
So
Avery?
that goes root 2 over 2. Does that make sense? Okay, how are we doing so far? We okay? 2 triangles. We need to know, by the end of this, all of the 30-60 angle ratios between 0 and 360, and all the 45s between 0 and 360. That's our goal. Okay? So, let us begin with the unit circle.
How big should we make it?
Pardon me?
How big?
Probably the rest of your page. Make it big. Make it big. You got a lot of information to fill in. Okay? So now, start this slow and easy process.
Segments?
Pardon me?
Are these 30-degree segments?
Yeah. There. Okay. All right. Now, we ready to go here? Oh. Well, it's not bad. One of these could move in. This guy could move it. Okay. All right, so again, we are talking about the unit circle. So the first thing I'm going to do is use the quadrantal axes and I'm gonna label my coordinates for it. Okay? So what is this coordinate right here if I'm talking about a unit circle? What's that coordinate?
1, 0.
1 and 0. Very good. What about up here?
0, 1.
Right here?
-1, 0.
And down here?
0,
-1. Okay, so that's easy enough, right? I forgot one thing I'm going to show you. Okay? Skip page here for a sec. One of the more important things that I want to show you is this. If I take any coordinate x, y on that circle, so again this is the unit circle, that means that that value is 1. Okay? I make an angle theta here. What's the distance from here to here?
Sine theta x
What's the distance from here to here?
y.
Y. Makes sense, right? The coordinate goes over x units and then up y units, yeah? Okay, great. Now, what is the ratio of sine theta here? Y over 1. So just y, you agree? Yeah. What cos theta? X. So in other words, if I'm looking at x and y here, those represent, on my unit circle, the ratio of the cos theta and the sine theta. Would you agree? So your x value anywhere along that circle is your cos ratio of that angle. The y value is the sine ratio around that circle of that angle. Okay, so we have to identify that first. Second, what does tan theta equal? Y over x. So if I'm talking about my coordinate cos and sine, what does it actually equal to? On? Louder. That's what I heard you say, right?
Yeah.
Sine theta over cos theta. So if you need to find any of the tan values, we don't write them out. If you need to find it, you take the y value of that coordinate and divide it by the x value of that coordinate, okay? Also, if that is the case, okay, in this quadrant, both sine and cos are positive, agreed? In this quadrant, my x is negative and my y is positive, yeah? So what does that mean? That means that my cos of my angle is going to be a negative ratio. So the cos of 120 is going to be negative 1/2. Okay? Down here, both negative, right? But what about tan? How do I find tan? Sine over cos. So a negative over a negative, which is positive. Good. And over here, cos is positive, y is negative, right? Sine is negative. So an easier way to remember this is what's positive in each of the 4 quadrants is that. Cos is positive here. They're all positive there. Sine is positive here. Tan is positive there. And the other ratios are all negative in those other 2 quadrants. 3 quadrants, sorry. Okay? So, just wanted to point that out. Because when I go back to this guy, it's going to make a difference. Alright. First things first. I'm going to write it along here as best I can. 30 degrees. Now I use my triangles. You got your triangles in front of you? What is the cos of 30? What's the cos of 30 degrees? Or?
3 squared over 2.
Not 3 squared.
Square root of 2.
Square root 3 over 2. And then what's the sign?
1 half.
1/2. So there's my coordinates, right? What are you looking for, Jake? No problem. Okay. So we did this in grade 11. Here is the add-on to it. I also need to write the radian measure for this. So what is 30 degrees in radian measure? Pi over 6. Good. We had already done that. Pi over 6. Okay? All right, let's look at 60 degrees now. What is the cos of 60 degrees?
1 half.
And what's the sine of 60 degrees?
Square root of 3 over 2.
Those values don't change. They just switch between 30 and 60. Okay? Now, if 30 degrees was 1 pi over 6, how much is 60 degrees?
Pi over 3.
Yeah, you're jumped ahead here. If 30 degrees is pi over 6, how much is 60 degrees? 2 pi over 6, right? Another pi over 6, which, Campbell,
Pi over 3.
when reduced is pi over 3. I don't suggest you remember pi over 3s. I say count them as pi over 6s. 1 pi over 6, 2 pi over 6, 3 pi over 6. 4 pi over 6, 5 pi over 6, 6 pi over 6. That's how I usually do it. But when you do the question, you do have to reduce it to pi over 3s. Okay? So let's go over to this other side here now. So this is 120 degrees. What is the coordinate for 120 degrees now? What's it the same as? Okay, so this is why we talk about reference angle. Remember, the reference angle is made with the x-axis, correct? So what's the reference angle for 120 from here down? It's 60. So now when I look at 60 here, it has to have the same values. It's 1/2 and root 3 over 2. What's the only change? Negative 1/2. So it's minus 1/2 and root 3 over 2. Okay? And I want the radian measure of it as well. So this is what I mean. Okay, what would you say it is?
2 pi over 3.
2 pi over 3. Every 60 degrees is 2 pi over 3. That's one way to look at it for sure. How I suggest you do it is go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Make sense? So 2 pi over 3. One more. 150 degrees. What's the coordinate for 150 degrees?
So I only, what do you
Negative root 3 over 2.
Very good. Negative root 3 over 2 and 1/2. Did you say negative? Okay. And what's the radian measure? Yeah. 5 pi over 6. How are we doing? So. Okay, I need to backtrack now. I should have done this before and I didn't. So I'm going to do it now. Let's go back to the quadrantal ones. That is 0 degrees, 0 radians. This guy up here, 90 degrees, pi over 2. Over here, 180 degrees, and 1 pi, right? Watch. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay, so far? Down here is 270. And 6, 7, 8, 9. 9 pi over 6, which is 3 pi over 2. And then we could go back to the start, and we could also say the start was 360 or 2 pi. We okay so far? All right. Now, I'm going to quickly switch here. The ones I haven't done yet. Are the 45s. What's the x and y coordinate for 45 degrees?
Square root 2 over 2.
Square root 2 over 2 and nope. Square root 2 over 2. They're the same. The sine of 45 and the cos of 45. Think about it. The angles are the same. Therefore, the sides across from them are the same. Therefore, the ratios have to be the same, right? So they don't change. So now I go 135 degrees over here. What's the only difference? I have a negative root 2 over 2 and a root 2 over 2. What is 45 degrees in radians? How much of the circle is that guy right there in the middle? Quarter. Awesome. So what is it? Pi over 4. That's exactly right. Good job. Okay, now think about it like this, guys. 1 pi over 4, 2 pi over 4. What's over here? 3 pi over 4. Right? So far, so good? Sort of. 2 triangles is all we're talking about. By the end of this, by the end of next week, I can say to you, what is the sine of 330 degrees? And you're going to say, what is it? Negative a half. Right? Because it's right there. It's my y value. It's that coordinate. Okay? We'll fill the rest of this in on Monday. I wanted to start this today. Okay, but we'll do the rest Monday. Alright? Zai? You got a couple more to write down? Okay. I'm going to eventually give this to you. I'll give it to you as you can have in your hand copy. Do you get this for the exam? No. What they do is they give you a blank template on your exam, and as soon as you walk in, the first thing you do in the first 5 minutes is do that first quadrant out. That's what you do when you get the exam, okay? Because you do have to know all of these, but you will get good at these. You use them a lot for the next month. You'll use them all the time. All right? Okay, you have 4.1 to do. You can get started on that right now.